So in previous classes, we discussed how to work with our YAML files and our deployments, services, ingress. So there is an other concept of namespaces. Let's check this out. So by default, we have default namespace. We have kube node lease, public, and system. I have created this metal LB and flannel as my networking namespaces. So by default, when the cluster is created, we have just two namespaces. And this my namespace, I have created it just for the testing and just to show you guys. So what are the namespaces? If we don't define any namespace, our project is created in the default namespace. Let's assume I am working on a cluster and I am working on some projects, let's say Apache PHP, and another guy or another team or another developer is also working on the same namespace, and he's deploying, he knows he's also deploying Apache PHP. So he may create a secret file, and I am using pretty standard usernames like root password, and maybe he's also using the word name password, and he's using different password, I am using different passwords. So our files, our secrets, config maps, our deployments, they can we can disturb each other's environment. Or let's say we have a lot of we have application which has a lot of pods deployed with different components. We have nginx running, we have Apache running, MySQL running, multiple containers of everything. So the environment can become too complicated, and we can use namespaces to isolate the stuff. Plus, we use namespaces if we have different teams working on the cluster. We can limit or assign resources. We can implement quotas that this namespace will have this much CPU memory, and this namespace has this much CPU memory. So it is just to organize your cluster. We use namespaces. So this is a small concept, and we discussed that how we apply the configuration. We do it like, before going to volumes, let's finish this topic. It is just we are discussing the theory here. So let's say I have my Apache deployment and I want to deploy Apache. So what we did was kubectl apply -f Apache PHP deployment, and when we do kubectl get all, so our deployment is created in the default namespace. So it's like get all -n default. So we are not typing -n default because it is always considering it default, and it always print the default settings. So let's say I delete this deployment, and I have my namespace created, my namespace. So if I tell it that create this project in the namespace, my namespace. So if I press enter and if I will do kubectl get all, so it will only show the configuration of default namespace, and the deployment is created in another namespace. So it will not show it, and we have to use switch my namespace. So in my namespace, our project is created, our deployments are created. So that's how.
Sorry to interrupt.
Yeah.
Just want to understand one thing. So basically, we want to group things together by
Yes.
using namespace.
Yes.
So will it have an effect in the backend as well, like the hard, like memory side or operating system side?
No. It's just for
Purely
the
for
ease of grouping the things, ease of management, and to avoid the conflicts.
Okay.
And it is not recommended. I mean, if you are working alone, or
Yeah.
maybe another team is working, I mean, it's not recommended to create namespaces or work in namespaces. I'm talking if the environment is big, so maybe, or the application is too big or complex, then maybe we need to group it together. Otherwise, working in default is fine.
Okay.
So, but this is a concept. So I just wanted to tell you that there is a namespace concept and it exists. I don't use it. And let me show you one more thing. So in our metadata, we will define the namespace as my namespace. If we don't define it, it is by default created in the default namespace. So then we don't need to use the switch -n. And if we define it in our file, everything will be created in the namespace which we have specified. So you want me to test it, or just we can go with the volumes? Let's see. I can test it when I am editing which Apache PHP deployment. Okay, kubectl get all -n my dash namespace. Okay, delete Apache PHP deployment. It is deleted. So let's see it again. It is not there. So if I do kubectl apply -f Apache PHP deployment, it is created. kubectl get all. It is not created in this namespace. I have not used the switch -n. Still, as I have defined it in my namespace, so it is there in my namespace. So this can be controlled on command line, and this can be done through your deployment file. So I am deleting this. Okay. And what I need to do again is it is deleted. Okay, this is the concept of namespaces and how we use them. Okay, one more thing. Volumes. Like Dockers. Storage. Yeah, like Dockers. Actually, we are using the Dockers or the container engine behind Kubernetes, and Kubernetes is an overlay or abstraction over the Dockers, and it is the management engine for, I mean, managing the container. So by default, in Dockers, we have studied that storage is not persistent. We have to do it manually. So when the pods are created, destroyed, recreated, the data is gone, because at the back end, the containers are destroyed and they are recreated. So the data is gone. So there is no persistence by default in Kubernetes and Dockers. So if we need persistence, we need to attach a local or remote storage to the pod. Like if I have an application in which, I will quote that example again, that I am receiving resumes of candidates in my website. So I have to download it somewhere. So that somewhere should be defined as a local storage or on a remote storage. So if the pod is crashed, the new pod can start from where the previous one has left off. So this can be DB, this can be our application. You can mount any path in your Apache container, and on your application, you can write to that path. So now we have a cluster. So the pod can start anywhere in the cluster. So if you can mount a local storage on node 1, there you cannot start your pod on any other node, because the data is available on that local node. And when the pod is started on another node, the data will not be available. So to cater for that requirement, we apply some affinity rules. Affinity rules are, we affiliate that pod on which the whole storage is mounted. We tell Kubernetes that always start this pod on this worker node. I mean, this can be done in a testing environment, but this is not a good uh, production practice. So if we have nothing available, we have no remote storage on Google Cloud, on AWS, nothing is available. So what we can do is, at least we can set up our NFS server. So NFS server is network file sharing server, and we can share the storage to all the nodes which we are working on. So the store can be NFS, local, remote, cloud, and okay. So volume types. We are talking about the volumes that storage needs to be created, and there are 3 volume types. In the persistent volumes, we create the persistent volumes, and the persistent volume is like your physical resource attached to your cluster, like CPU and RAM. I mean, it is available globally. Sorry, it is available globally. Your persistent volumes, and you claim those volumes using another attribute, persistent volume claims. If I can go on board, so I was saying, this is our node, and this is my workspace. Let's say, and we are creating containers, and we have a CPU installed, we have RAM installed. So what I am saying is, this persistent volume, like it's a block of storage, 10G, 5G, 1G. So this is the persistent volume, can be a local disk or can be a remote NFS server or Google Cloud Storage. We define, the system administrator defines that this is 10 GB persistent volume, and the developer through PVC checks what volumes are available and how much I need. So let's say he needs 5 gigs of space. So he will search for 5 gigs space volume, and he will connect to this volume. Any confusion? Are you not getting it?
Yeah, this one I didn't get that about this. You said these are
We have 2
three.
concepts. The 2 concepts: the PV and the PVC. PV is persistent volume. I mean, we could have done the same command that this is mounted directly inside, but there is a problem to it. You are a developer, you don't care from where this 5 GB will come. But as a Kubernetes administrator, as I told you, this should be a remote storage. Either this will be on cloud, so I need to pay it, or it should be on NFS. And if it is on NFS, so I am a Kubernetes cluster administrator. I know I have, let's say, 100 gigs of NFS available. So I will decide that, okay, to this team, I will give, if I have 100 gigs available, I will give this team 40 gigs, the other team 40 gigs, and let's say I will reserve 20 for some other purpose. So the Kubernetes administrators knows how much backend storage is available, and of course he has to take the backup of that storage, because Kubernetes don't care if the storage is gone. Nothing is there. So the storage, the remote storage, should be highly available. The Kubernetes administrator should take backup of it or replicate it, so that if, let's say, it is gone, then the recovery mechanism should be available. So he mounts, or he makes it available for the cluster. Now the development team, the developers, They have their containers. For those containers or pods, they need the storage. So they will search what storage is available, and they will connect to those volumes and mount them in their pods. So to manage the physical resources, there will be another guy, which will the Kubernetes administrator, and he will create the persistent volumes. And those volumes will be claimed by your pods or your developers. Am I able to explain or not?
Yes, the thing is clear, but and one more.
No, the lab will tell it. The lab
Oh.
will tell it. So it's just the concept, small concept, and we can implement. It is again the theory. And let's go on the slide again.
So the volumes are attached to cluster, not to nodes.
The volumes are
attached to pods.
yes, the PVs are the persistent volumes are attached to node.
Nodes.
Okay.
I mean, node.
Also-
They are shared with the nodes.
So basically, it will be on a cluster. Like the volume will be mounted on cluster.
They should be
And-
available on every node. I mean, the cluster is made of, let's say, 100 nodes. So this
Yeah.
volume should be available for 100 nodes. When we
Okay.
let's do the lab and we will get it. Okay. So persistence volumes are defined globally and not namespaced. I mean, they are not defined in any namespace. They are available globally. So every if two teams are working in their separate namespace, they can use this physical volumes. And next is persistent volume claims. Persistent volume claim is defined in namespace because the persistent volume claim is used by your team. I mean, the developers team. So it should be in the same namespace where the team is working. And from that namespace, you can connect to the physical volumes. I told you the advantage that PVs can be managed by cluster administrators as they know the availability and limitation of physical infrastructure. And the volumes are claimed by users who do not care what backend storage is, and they work only with the application. So it is actually less of the worry for the developers that from where the storage is coming. So you know the storage is there and you do it, your application work. So you are relieved from the storage part. And there is a third component, storage class. PV and PVC are automatically created by storage class, and this confusion is reduced. But for that, you have the remote storage. We can use GCP, AWS. The syntax is available on Kubernetes website. You have credentials, you have storage on GCP. So we will provide the path and credentials, and we can mount that cloud storage in our clusters. Okay, local versus remote volumes. I told you you can mount a local hard disk, but that if let's say you have a local hard disk, you create a directory data and you mount your pod to that data directly, but that data is not available on the node 2. So we will have to apply the affinity rules and we will look into it. So whenever the pod is created, it is created on the same host where you have shared the data, so that the data is available for the pod. Remote volumes are available to all the nodes, so pod can be started anywhere. This is our PV. It is also created through the YAML file. And if you can see, I have defined our NFS server. So you have the idea of an NFS server. What is an NFS server? NFS server is network file sharing server. I can show you the server. And the path is NFS share. On that server, I have shared a path, NFS share. And this path is available to all the hosts. It's the cluster administrator's responsibility that this path or this IP is reachable with all the nodes. Okay, then we can define the access modes. Access modes can be read-write once. So the volume can be mounted as read-write by a single node. Read-write once access mode allow multiple pods to access the volume like one is master and all others are the same. One is master node who is reading and writing, and all others are just mounting it as read only. The advantage is you have a big application, either anyone can write into it, or only you can allow one master server that yes, only this master server will write it and all the rest of them are the slaves. Then okay, the access mode can be read only many and read write many, so that if you want everybody can write, so everybody can write. So mostly we use read write once because one pod is attached to one storage, but depending on your application requirement, we have all the options available and tons of all other options, but we are discussing the more general terms here. Capacity is what? Storage capacity is, you can say 1 GB, 10 GB, 100 GB, depending on your physical resources availability. So the storage class name is, I am saying that I am creating it manually, or it is my NFS share. So you can name it anything, but then you need to call it in the PVC by this name. And this is PVC. That was persistent volume, and this is the kind persistent volume claim. So in the claim, we defined the same class name. We had defined manual, so we will define manual here. We had defined read write many there, so it is better that we define read write many here. And the resources is, I want to request even 500 mega information bytes. Even if 1 G is available, I can claim only 500 MB. This is an example of local storage. Everything is the same, and the difference is, okay, volume mode. Volume mode is file system. If we don't define the volume mode, it is by default selected as file system, but we can connect a block storage to it. But mostly we are working with file systems which are already formatted. So access mode is read. So storage class name is local storage and local path. We define local. Okay, if we define NFS, the parameters are changed. If we define locals, the below parameters are changed. If we define like say remote, the parameters are changed. For GCP, there will be different parameters. So for AWS, there will be different parameters. So path is, I want to mount slash data. So I have created a slash data folder on my node 1. And this is the node affinity, that the pod is created on worker node number 1 only. So the syntax is, this is the node affinity syntax required. So what are the selector terms? So what expressions we need to mount, and the Kubernetes IO, like to API, we are telling that we are searching the host name and the operator is in values, the host name is worker1. So we can select with OS version and we can select with a lot of things, but we are selecting the host name that this pod will be created on worker node 1 always, as I have shared slash data folder inside that physical node. So too much theory, everybody is so much bored. Let's say if we can create something and I can show it physically. I mean, you guys are so bored. I know, I get it. Nobody's speaking. Am I right?
No.
I need to share. Okay, I am stopping the share for just 1 minute. Okay, this is my NFS server. And its IP is IPAS. The IP address is 129. I have a directory cd var nfs share on which some data is available. I mean, this is actually example.com database. I can remove it. rmnsrf static. Okay, this is my nfs share. vi etc exports. So this is my worker node 1. I can increase the size, change settings. You are able to see the screen, right? The NFS server.
Yeah.
Yes.
Okay. So this is, I have created this share. And I told that 192.168.1.37 node 1, 138 node 2, 139 node number 3. On all the nodes, this share is available. Leave this read write sync no root host squash. This is the syntax of sharing a volume. So this NFS share is available on all my nodes. And I have mounted a different share with my VMware. I mean, I was working on a shared storage. So this is my VM. I can share the storage using this VM. And now going back to our presentation, yes, share. And more etc hosts. And let's say if I go into my worker node 1, yes, okay, yes. So this NFS share, var NFS share is mounted on data on my all the nodes, so that I can show you if I touch a file test.txt. So it is, I have created a test.txt in my worker node 1. And I can exit from here and I can go to my worker node 2. Come on. When I go to data, this test.txt is available. So we are sure that our shared storage is available to everyone. And if I delete it from here, if I add it from, everything is available to all the hosts. Let's say we can grow in our project. I can clear anything. The concept of shared storage is clear, correct? Yes, Mohsin?
Yeah, yeah.
So the storage is shared. We have checked it. So let's go in our PV. So PVNFS. I have created this file PVNFS. It is the persistent volume claim. I named it PVNFS. Labels, you can ignore them. Capacity is 1G. So let's make it 10G. And volume mode is, it's a file system. Read write once because I am attaching it to one pod only. Storage claim name is NFS. And the server IP address is 192.168.1.6.129. We have just seen that this server is available. Oh, sorry. This server is available and the share path is var NFS share. So when we do the kubectl apply -f pv -nfs .yaml. So our share is created, and if we do kubectl get pv, so okay, it is not available. It is already bound. Let's clean everything. del delete this. Maybe I have used it in some container also. pv dash get pv. Okay, that one is terminating. So, and we can check the PVCs. This is a PVC NFS actually. This is deleted. So no resources found. Okay, it was not terminating because some pod was using it. Again, kubectl apply -f and pvnfs. So I am the application developer and I will see kubectl get pv. What volumes are available? Okay, I have this available. It is not bound to anything. pv dash local storage. So I can, now I have two PVs available. That's not PVNFS. It is not able to find it. So kubectl get PVC. It is pending. So if I can apply it again, kubectl apply -f PVC. I have to delete that first. And then apply again. It is created now. Kubectl get PV. Good. It is now bound. It is now bound to this PVC. Right. PVC. And the name was PVC-NFS. Okay. So we can describe if anything is wrong, you will know it. But the class is too silent today. Are you guys available or you are gone? Or you are
So
having some issues?
I have one question. So
Yes.
why do we need to go through PVC? Can't we directly use PV?
I told you
He named it.
the developer and the cluster administrator, these are two jobs. You don't know how much storage is available on the backend, correct? If I have 10
Yeah.
GB NFS, you want to provision 100 GB NFS, you don't know the backend infrastructure. So how do you know how much physical storage is available? Correct?
Okay.
So the system administrator, the Kubernetes administrator knows how much physical storage is available. So he will make this available to you guys, to the developers.
Okay.
So this is why we have the concept of PV and PVC. PVC is you just claim it. The developer will just claim it. Making
Okay,
it available is the job of the cluster administrator. And then there is another concept, like we are working in the those days, the storage is not a limit and cloud is available. So when we are using cloud and we have no issue of like how much billing is generated, so there is a concept of storage class. On that, this complete flow can be done automatically. But I have no GCP account, so I cannot demonstrate it, or I don't have an AWS account right now. So I am working with the NFS, and I am the NFS administrator. I am the Kubernetes server administrator. So I know I have 10 gigs available. So I have made 10 gigs available. I can make, okay, you are the developer. You can say that, okay, no, I need 100 or 10 more. So I will see if 10 more is available. If available, I can increase it. If not available, I can say, okay, sorry, that's it. We don't have further storage. We have to buy it or whatever. So this needs to be bifurcated because the physical storage is the limit. And the developer cannot know it. It is the infrastructure guy who knows it.
Okay, got it. And can we do like dynamic memory allocation?
Sorry, you come again?
Can we do dynamic memory allocation?
Dynamic memory allocation for what?
Yeah, instead for PVC, instead of specifying 10 gigs of memory, can we do like on the fly?
Yes, you can increase it. I mean, you want to say that you can increase from 10 to 20?
Yeah, like we don't need to specify the amount of memory required.
No.
But it should be.
You have to tell how much space do you need. I mean, we cannot leave it open-ended.
Okay.
So we have to define it.
Got it.
So final step is we have our PVC, we have our PV. And what I want to do is I have my SQL deployment, and under specs, the persistent volume claim name was PVC NFS, or it was just NFS?
PVC.
PVC, it was NFS. Oh no, it is
So the
PVC.
name PVC and FS, right?
PVC NFS, yes. So I will call this claim PVC and NFS under volumes, and under container I will tell volume mount path, and that mount path will be var lib MySQL in case of MariaDB. It will be var www.html for Apache. For Nginx, it can be different, and for your custom application, you can define any path. So this var lib MySQL will be mounted on this NFS, and all the data will be written on that remote storage.